Hi guys! In this lecture, we'll go over Jupyter Notebook, which is probably the most popular Python development environment for machine learning and deep learning, data science and data visualization. This is what I'll use throughout this course. In this video, I'll show you how to install and use it. If you already have some experience with Jupyter Notebook, you can skip this video. And if you prefer to use any other IDE like PyCharm or VSCode, you are free to do so. At the end of the day, it doesn't matter where you write your code as long as it works. The name Jupyter is an indirect acronym of the three core languages it was designed for: Julia, Python, and R, and is inspired by the planet Jupiter. What is in fact Jupyter Notebook? It's a web application that runs in the browser in which you can create and share documents that contain live Python code, equations, visualizations, as well as text. At this moment, I suppose you have already downloaded and installed Python. If not, just go to python.org, downloads, and install the latest version of Python. Go with the defaults, just select Add Python to Path when you are asked. Let's install Jupyter Notebook on Windows. If you use Linux or Mac, you'll follow almost the same steps. The installation is simple and we are going to use pip. In the terminal, I'm running pip install IPython and Jupyter. It's downloading and installing the required components. If you get a pip command not found error, it means that pip doesn't belong to the Windows path. To fix it, you will either need to reinstall Python and check the box to add Python to the Windows path, or add pip to your path manually. We are waiting a few more seconds. The installation was successful, so let's start it. I'm going to create a new directory where I'll store all notebooks. The notebooks are files created by the Jupyter Notebook application and contain both Python code and other rich text elements like paragraphs, figures, tables, equations, or images. You may create the directory wherever you like as long as you have the necessary permissions. To keep it simple, I'll create the directory on the desktop. So cd desktop and mkdir OpenAI /API. Now let's start Jupyter Notebook. In the project directory, so cd OpenAI _API, I'm running Jupyter Notebook. Note that in the future, it's important to run the command Jupyter Notebook only from this directory. The default browser is opening up and we can see the root of our Jupyter Notebook application. Here, I'll create a new notebook by clicking New and Python 3. I'm also giving it a name. Let's go ahead and see how to use Jupyter Notebook. We'll write our Python code in a cell and then we'll run the cell. For example, print hello Jupyter. And x equals 10, I'm defining a variable, and x. It's not necessary to use the print function in order to display x. You can execute the code inside the cell by clicking anywhere within the cell and then the run button. I'm clicking run. And it executed the code within the cell. You can also run the code within the cell by pressing Ctrl Enter or Shift Enter. Ctrl Enter runs the current cell and Shift Enter runs the current cell and then inserts a new one below. For example, print x to the power of 2 and I'm pressing Shift Enter. The cell was executed and a new one appeared below. When you are done with your notebook, you can save it by clicking Ctrl S or by going to File and then clicking on Save and Checkpoint. There are two types of cells: code cells, where you write Python code, and markdown cells. Markdown is in fact a markup language that is a superset of HTML. Text can be added in markdown cells. You can change the cell type by selecting code or markdown here, or by pressing Escape and then M for markdown or C for code. You can use simple features to format your text in a markdown cell. Let me show you some basic text formatting you can do in a markdown cell. Okay, this is a markdown cell. To create a heading, add 1 to 6 hash symbols before your heading text. The number of hashes will determine the size of the heading. For example, Python lists and methods. I've created 2 headings. You save the cell's content by executing the cell. Press Ctrl Enter or Shift Enter to execute the cell. You can make the text bold by using 2 stars before and after it. If you use a single star, the text will be in italics. For example, 2 stars and the text. This is an example of bold and italic text. I'm using a single star before and after and italic to be in italics. Bold and italic. You can indicate a command or a piece of code within a sentence using single backticks. For example, 2 backticks and append is a list method. Let's move on. You can make an unordered list by preceding 1 or more lines of text with a dash or a star. For example, Python methods, append, insert, pop, and so on. I've created an unordered list. Okay, I think these are the most frequently used markdown formatting options. Let's return to code cells. If you do something in a code cell, like creating a variable or a function and running that cell, those names will also exist in the other cells of the same notebook. For example, I'm declaring a variable x equals 100. I'm running the cell. Now, x exists in other cells of the same notebook as well. X times 2, 200, and I can even write the code above that cell, x minus 10, and I'm running the cell, and it's 90. If you want to insert a new cell before another cell, press Escape to enter the command mode and then A. Enter will take you from command mode back into edit mode for the given cell. And if you want to insert a new cell after an existing one, click the gutter of that cell and press B. So A is before and B is after. While the code in a cell is running, you'll see an asterisk on the left part. Let's try an example. Import time.sleep of 3. It's sleeping for 3 seconds. And print 5. And I'm running the cell by pressing Ctrl Enter. Take a look here. Take a look at this star. It is displayed while the cell is running. You can delete a cell by selecting the cell by clicking on its left gutter and then double D or DD. I'm deleting cells. Tab is used for auto-completion and Shift Tab is used to show the help of a function, method, class, or module. For example, L equals list. L dot A P P and I'm pressing tab. And it has completed the name of the method. Okay, we are almost done. You can also check the help menu to learn how to use it efficiently. Note that you can also download the notebook in another format. To close Jupyter Notebook, in the terminal where you've started it, press Ctrl C. Connection failed because I closed it. Okay, we are done with Jupyter Notebook. At the end of this video, I need a few more seconds to tell you about Google Colab. If you are unable to install Jupyter Notebook, if you don't have the necessary permissions, or for any other reasons, you can run your Python code in Google Colab. Google Colab, or Google Collaboratory, is a free notebook environment that runs entirely in the cloud. You don't have to install it locally. It's integrated with Google Drive and lets you edit notebooks and share them with your team the same way you work with Google Docs. Another perk is that it supports free GPUs. To use Colab, all you have to do is sign into your Google account, go to Drive, click New, and then Google Collaboratory. If you don't see Google Colab in the list, click Connect New Apps and install it. It's pretty simple. Or go to colab.research.google.com and then click New Notebook. Now, you simply start writing Python code. Print hello Colab. And x equals 1, 2, 3. This is a list. Print x of 1. And I'm running the cell. I'm clicking this arrow here. Another advantage is that it allows anyone to develop data science and deep learning applications using popular libraries such as PyTorch, TensorFlow, Keras, and OpenCV. Most of them are already installed. Import Torch and import Keras, import Pandas, SPD, and I'm running the cell. These libraries are already installed and available. This video is not about Colab, but I think it deserves some time on your part to play around with all the features it has to offer. That's it, thank you. Let's get started. In this video, we'll go over creating an OpenAI account and an API key. What is an API? API stands for Application Programming Interface and is a mechanism that enables two software components to communicate with each other using a set of definitions and protocols. For example, think of a weather forecasting service that offers daily weather data. The application on your phone talks to this service via API calls and shows you daily weather updates. In the same way, we can talk with the OpenAI models such as ChatGPT from our applications. You can interact with the OpenAI API using HTTP requests. There are official libraries for Python and Node.js, but also community-maintained libraries for other programming languages. Take a look here. As you can see, there are also community libraries for C#, Go, Java, Ruby, Unity, or Unreal. By the way, the last two are game engines, so if you are a game developer, you can use the OpenAI models as well. To use the AI models developed by OpenAI, all you need to do is open an account and create an API key. Open up your browser and go to platform.openai.com/signup. Here, you can create your account. I already have an account and I won't walk you through every step needed to create yours because it's pretty straightforward. You can also use your Google or Microsoft accounts, or you can create a new one using your email address. Note that you may need a valid phone number to confirm your account by SMS. Once logged in, you can create an API key that will be used to authenticate to the OpenAI backend. In the right upper corner, click your name and then View API Keys. In this window, you'll see your API keys, which by the way should be kept secret. Anyone who has access to your secret keys can impersonate you and make requests on your behalf. This can also be translated into spending money because the use of OpenAI models is not completely free. This is the reason why the keys are not listed in clear text. To create a new API key, click Create New Secret Key. And a new key is generated. At this point, you should save the key somewhere safe because this is the only time when you can see it. If you don't save it now, or if you lose it, you'll have to generate a new one. This is in fact what this pop-up window says. Note that if you don't need a key anymore, or it gets compromised, you can revoke it. This being done, we now have an OpenAI account and a valid API key. We'll take a short break, and in the next video, I'll show you how to install the OpenAI API and how to authenticate to OpenAI. Hi everybody and welcome back. In the last video, we signed up for an OpenAI account and created a secret API key. In this video, I'll show you how to authenticate and access the AI models developed by OpenAI using the official OpenAI API and Python. This is really cool because this is how you empower your applications with artificial intelligence. There are two native and officially supported APIs for Python and Node.js and many other community APIs for other programming languages like C#, Java, Go, and so on. I'm opening a Jupyter Notebook and creating a new notebook. The first step is to install the OpenAI library, which is a Python client for the OpenAI API. You can do it using pip. If you don't use Jupyter Notebook, but other IDEs like PyCharm, for example, the installation is very simple. Let me show you how to do it. This is PyCharm. In an empty Python script, write import OpenAI. Hover the mouse over the library name, and when a small window is popping up, click Install Package OpenAI. And that's it. It's installing the package OpenAI. Let's return to Jupyter Notebook and install the library using pip. You can run the command directly in the terminal or in the Jupyter Notebook. If you run Jupyter Notebook in a virtual environment, don't forget to activate the environment and run the pip command in that environment. To run a command in a code cell in Jupyter Notebook, write an exclamation mark and the command. For example, pip install -q OpenAI. And I'm running the cell. -q comes from quiet and makes pip give less output. It's installing OpenAI. You do the same if you use Colab, the popular online IDE from Google. An exclamation mark, pip install -q OpenAI. And I'm running the cell. It's downloading and installing the OpenAI library. The library was installed and I'm importing it. Import OpenAI. I'm also importing OS because I'll need it. And I'm running the cell. To use the OpenAI API, we have to authenticate, and we'll do it using the API key we've just created. The recommended way is to set the secret key as an environment variable, and I'll do that using the OS module. To create a new environment variable, write os.environ and add the name of the variable as a key. For example, x equals ABC. In this example, I've created a new environment variable called x with value ABC. And to retrieve the value of the variable, call os.getEnv and the name of the variable. And I've got its value. Now I'll do the same for the API key. The name of the environment variable will be OpenAI API key. So os.environ of OpenAI API key in capitals and the API secret key. Note that the key should remain secret so that after creating the variable and running the cell, you should remove it from your code. In this example, I leave it here because I want you to see the entire code. However, this key won't be valid when you'll be watching this video. Next, I'll assign the environment variable, so the key, to OpenAI.API key. So OpenAI.API key equals os.getEnv of and the name of the variable. Let me show you an alternative solution to this. Instead of writing the key in the notebook in clear text, you can prompt the user for it. I'll use the getPass module because I don't want to display the key in clear text. getPass is an alternative solution to the built-in input function. So, import getPass and the key equals getPass dot getPass. The first getPass is the name of the module, and the second one, the name of the function. And the message for the user. For example, paste your API key. And the OpenAI.API key equals key. I'm running the cell. At this moment, the user should paste his API key. I'm pasting my key. As you can see, the characters of the key string were replaced with asterisks. This is what getPass does. And finally, the last solution to load the key is to read it from a file. In the current directory, I've saved the API key to this file and the code to load it into OpenAI.API key. So OpenAI.API key equals open and the name of the file key.txt .read .strip and the \n. I'm running the cell. So I'm opening the file in read mode, which is the default one, and reading it into a string. The strip method is optional, and I've used it because some users add a new line at the end, and that new line should be removed. That was the authentication part. I've shown you 3 ways to load the API private key. Feel free to use the one that suits you best. We'll take a break and we'll continue with OpenAI models and see how to make GPT-3 and the ChatGPT requests using the API in Python. I'll see you soon. Welcome back. We have an OpenAI account and an API key that is saved in an environment variable. The next step is to start making requests to the OpenAI models. We'll do that soon, but for the moment, I want to tell you a few words about the AI models that are available so that you can choose the right one. In this lecture, we'll go over OpenAI models. I've used the word model many times, but what is an AI model? Generally, an AI model is a software program that uses specific algorithms and has been trained on a set of data to perform specific tasks like completing text, generating images, or recognizing certain patterns. AI models use machine learning and deep learning algorithms to learn from the training and apply that learning to achieve specific predefined objectives. The OpenAI API has access to a family of models, each with different capabilities. Note that you can also customize the models offered by OpenAI for specific use cases, and this is called model fine-tuning. OpenAI provides us with access to the following model families. GPT-3 and the GPT-3.5 are a family of models that can understand and generate natural language. GPT-3 consists of these specific models, where DaVinci is the most capable but also the most expensive, and Ada is the simplest but at the same time the fastest and the cheapest. The other models are in between. You can find information about their price here at this URL. GPT-3.5, as its name suggests, is a family of models that improve on GPT-3. The most capable and also the cheapest in this family is GPT-3.5 Turbo. This is optimized for chat, generating both natural language and code, creating embeddings, editing text, and other traditional tasks. ChatGPT is powered by GPT 3.5 Turbo, the most advanced OpenAI model and the recommended one. But if you have very simple tasks and a low budget, you can take the other models into account. Also, note that any task performed by a cheaper and faster model like Ada can be performed by a more powerful model like DaVinci or GPT 3.5 Turbo as well. You can use the playground to run and compare different models, settings, outputs, or response times. Let's put both Ada and DaVinci to answer a simple question. So, 3 Dax is the capital of France. I'm selecting text DaVinci 003 and clicking submit. And it says Paris. It practically replaced the first 3 Dax with the answer, which is Paris. This is really smart. Now, let's try the same thing using Ada. And we notice that it answered correctly with Paris is the capital of France. However, it didn't know that I actually wanted to fill in the blanks and returned the whole sentence. This is acceptable. Now, let's try a more complex task such as a translation. So, translate the following text from English to Romanian. By the way, Romanian is my native language. And below, text, colon, how are you today? And the translation, colon. I'm selecting text DaVinci and submitting it. And it did a pretty good translation. Now, the same task using text Ada. And it wasn't able to complete the task. Instead of that simple translation, I've got something else. So Ada has failed. You can play around with all these parameters here in the playground. The most important ones, such as temperature and penalty, will be discussed in detail later in the course. Let's get back to OpenAI models. Besides the GPT-3 and GPT-3.5 families, there are other models as well. DALL-E can generate images from text descriptions, can create variations or edit existing images. We'll see DALL-E at work soon. Whisper is a general-purpose speech recognition model. It was trained on a large dataset of audio and is also a multitask model capable of multilingual speech recognition as well as speech translation and language identification. This is pretty cool. This was an overview of the most important OpenAI models. In the next video, we'll start making GPT-3 and the ChatGPT requests using the OpenAI API and Python. I'll see you soon. What will follow is extremely valuable. You'll learn how to make your application talk to the latest OpenAI models. Alright, we have an OpenAI account and an API key that is saved in an environment variable. The next step in making a request is to create the prompt, which is probably the most important part when working with large language models. You input some text as a prompt and the AI model will generate a text completion or an image that attempts to match whatever context or pattern you have given it. For example, if you give it the prompt, write a motto, for a football team, it can return a completion like victory requires dedication or something else. Okay, this one is very cool. Designing your prompt is extremely important, and that's why a new field called prompt engineering has emerged. There are forums, groups, or even cheat sheets with cool or useful prompts. I'll go deeper into prompt engineering in another video. For the time being, I want to make a request to a text completion AI model. Now, I'll show you how to make requests to the GPT-3 family of models. The newest and the most powerful models in this family are DaVinci and the GPT 3.5 Turbo, which is used by ChatGPT. Okay, I'm writing a variable for the prompt. Prompt equals write a motto for a football team. In the first example, I'll show you how to make a request using a model from the GPT-3 family, such as Text DaVinci 003, and in the second one, how to make a request using GPT 3.5 Turbo. To create a GPT-3 request, call OpenAI.completion.create. This method will take some parameters and will return a response object. So response equals. When calling this method, I'll use keyword arguments, which means to write the name of the argument equals and its value. This way, you don't have to worry about the order of the arguments. The first argument is the model name, and it should be one of the available OpenAI models of the GPT-3 family. Take a look here. This family of models, called GPT-3, can understand and generate natural language. There are more text models available, with DaVinci being the most capable, while TextAda is the fastest. By the way, ChatGPT, which is considered a GPT 3.5 model, is also based on Text DaVinci. So, model equals Text DaVinci 003. Take a look at the documentation because the name of the model can change in the future. The next argument will be the prompt. So, prompt equals prompt. This is the method's argument, and this is my variable, the one I have declared. After the prompt, there are two more parameters, temperature and max tokens. Let's say temperature equals 0.8 and max tokens equals 1000. What is the temperature? The temperature is a parameter that controls how much randomness is in the output. The higher the temperature, the more random the answer will be. The temperature can be between 0 and 2, and the default is 1. If you set it to 0, the model outputs will be mostly deterministic, and if you increase it, the output will be more diverse but more prone to errors. And the max tokens is the maximum number of tokens to be generated in the completion. Remember that you'll pay per 1k tokens and that each model has a context length. For example, both Text DaVinci 003 and the GPT 3.5 Turbo, the model used by ChatGPT, have a maximum length of 4096 tokens. Both input and output count toward this limit. Note that these two parameters are optional. That's it. I'm running the code in this cell. Okay, sorry, there's a spelling error. Of course, is DaVinci. I'm running it again. There's no error, and I've got an OpenAI response object. Let's see it. Print response. We notice it's a JSON object which is represented somehow as a Python dict. To get the response, we access the value of the key choices and we'll get a list. The list has one element and that means index 0. So R equals response of choices of 0 and print R. Okay, now I've got another dict, the element of index 0 of the list, and the API answer is the value of the key called text. So, text. And I've got the text response or the text completion. The motto is very cool. Teamwork makes the dream work. Okay, we are done for the moment. In this video, you've learned how to make API calls to DaVinci. We've also learned about different parameters used in the call so that you can customize the request. In the next lecture, we'll see how to make ChatGPT requests. I'll see you soon. I can't tell you how excited I am to record this video. I'll teach you how to bring the latest artificial intelligence to your applications. So stay with me to the end. Alright, in the last video, we talked about GPT-3 and DaVinci and how to use them in our Python application. Let's go ahead and see how to make a ChatGPT request. This is a GPT 3.5 family of models that is optimized for dialogue. In a new cell, I'm creating the prompt. We can optimize the prompt for each specific model, but for the moment, we'll use a standard question. So prompt equals, let's say, tell me the name of the largest city in the world. Instead of sending a single string as a prompt, as we did with GPT-3 DaVinci, here, for ChatGPT, we have to send a list of messages as your input. The next step is to create the structure of the messages. This is a list of dictionary objects. List and dictionaries. This will be the structure of the messages. Each object or message in the list has two properties, role and content. The role can take one of three values: system, user, or assistant. So the roles can be system, user, and assistant. And the content contains the text of the message of the role. Conversations can be as short as one message or fill many pages. Typically, the conversation is formatted with a system message first, followed by a user message. The system message helps set the behavior of the assistant. We can instruct the bot to play a specific role. You'll see it in a moment. And the user message is what you ask the assistant. They can be generated by the end users of an application or set by a developer as an instruction. Okay, I'm adding the system role. So role, colon, system. And the content, colon. Let's try something simple. Answer as concisely as possible. And the user role. So role colon user content colon prompt. The variable I have defined. And I'm removing the assistant role. I don't need it for this example. Now I'll create the completion object. So response equals OpenAI .chat completion .create. Chat completion with a capital C for chat and another capital C for completion. And model equals the name of the model. ChatGPT uses GPT 3.5 Turbo. Messages equals messages, my variable. Temperature and the max tokens, which are optional. So temperature equals 0.8 and the max tokens equals 1000. I'm running the cell. It's done and I'm printing the response. And this is what I've got. The assistant answered with Tokyo. Tokyo is the largest city in the world. Note that ChatGPT is not connected to the internet, so it may not have the latest information. Let's get the assistant answer. So, response of choices, and I'll get a list. This is the list. The list has one element, so index 0, and that element is another dictionary. The key is message, another dictionary, and finally content. And I've got its answer. Note that you can also access it like this. Print response of choices, index 0, dot message, dot content. It's the same. Okay, now let me tell you a few words about the system role in the messages structure. The system message allows us to set the behavior of the assistant. In this example, the assistant was instructed to answer as concisely as possible. Let's see what happens if we instruct it to answer as detailed as possible. So, answer as detailed as possible. I'm running the cell and I'm printing the response. And we see a difference. It gave us a more detailed answer. We can even instruct it to play a specific role. I want it to answer as Yoda from the Star Wars movie. So answer as Yoda, Master Yoda, from the Star Wars movie. I'm sure you know who the legendary Master Yoda is and how he talks. Okay, very nice. The name of the largest city in the world? Tell me, Tokyo it is. One last remark. This is an extremely fast-moving space and minor changes could happen in the future, so I recommend you to check the official documentation for the latest version at this link, platform.openai.com/docs/guides/chat, just to be sure that you are up to date. Up until now, we've seen how to use the OpenAI API in our Python application to make GPT-3 and ChatGPT API requests. Up next, we'll dive deeper into ChatGPT and see how it really works. Bye bye. Hi guys and welcome back. Up until now, we've used the OpenAI API successfully to get data from AI models like DaVinci or ChatGPT. In this video, we'll go deeper into ChatGPT and see how it really works. The models that power ChatGPT focus on the following areas: large language models, self-attention mechanism, and reinforcement learning from human feedback. And this is what makes ChatGPT unique. By the way, GPT means Generative Pre-trained Transformer. A transformer is a deep learning model that adopts the mechanism of self-attention to differentiate the significance of each part of the input data using weights. Large language models digest huge quantities of text data and infer relationships between words within the text. Large language models, or LLMs, increase their capability as the size of their input datasets and parameter space increase. However, there are some issues and limitations with LLMs. The issues are capability and alignment. In this context, capability refers to a model's ability to perform a specific task or how well it is able to optimize its objective function. Alignment, on the other hand, is concerned with what we actually want the model to do versus what it has been trained to do. Simply put, it shows to what extent the model's goals and behavior align with human values and expectations. LLMs, such as the GPT-3 family of models, are misaligned because they are trained on vast amounts of text data, articles, books, and so on from the internet, and are capable of generating human-like text, but they may not always produce output that is consistent within the human expectations or desired values. This misalignment is due to their objective function, which is a probability distribution over word sequences that allows them to predict what the next word is in the sequence. The alignment problem in large language models typically manifests as model hallucinations, when the model is making up unexisting or wrong facts, lack of interpretability, when the humans don't understand how the model arrived at a particular decision or prediction, and generating biased or toxic output. If the language model was trained on biased or toxic data, it may reproduce biased or toxic data in its output, no matter how it is instructed. Let's go ahead and see why a model can produce misalignment. GPT-3 family of models, and this includes GPT 3.5 Turbo used by ChatGPT, are generative models. The core techniques used for training are next token prediction and masked language modeling. Next token prediction means that the model is given a sequence of words as input, and it is asked to predict in a reasonable human-like way the next word in the sequence. And the masked language modeling approach is a variant of the next token prediction in which some of the words in the input sentence are replaced with a special token, such as mask. The model is then asked to predict the correct word that should be inserted in the place of the mask. For example, if the model is given the sentence, the area of a circle is mask in square brackets times the radius squared. The model is filling in blank with the most statistically probable word given the surrounding context. And that's the pi constant. But if I'm asking the Roman Empire mask in square brackets with the reign of Augustus, the model may predict that the mask position should be filled with began or ended because the occurrence probability of both works is high. And it replaced the mask with began. To overcome this possible misalignment in large language models, OpenAI uses a specific technique called reinforcement learning from human feedback. ChatGPT is the first case of the use of this technique for a model put into production. But what does reinforcement learning from human feedback mean? Let's ask ChatGPT. As you can see, reinforcement learning from human feedback is a training technique used by deep learning models. They interact with an environment and receive feedback in the form of rewards or penalties based on their actions. The model also receives feedback from a human expert who provides guidance on how to improve its performance. Human feedback can take various forms, such as correcting misclassifications, providing additional training data, or suggesting changes to the model architecture. This technique was described in depth in an OpenAI's 2022 paper that you'll find attached to this video. Alright, well done. Now you have a good overview of how ChatGPT works. Next, we'll go over some other important concepts used by large language models such as the GPT family. We'll talk about tokens, model completion parameters in depth, the system role, and prompt engineering. This will really put you on top. In this video, I'd like to go over costs. Using the OpenAI API is not free of charge. Fortunately though, at the moment of creating this course, OpenAI gives a free credit that can be consumed within the first 3 months. This is in fact a great way to learn and test the service. The cost of using the ChatGPT API was reduced dramatically. A series of system-wide optimizations have reduced the cost of ChatGPT by 90% since its initial release in December, and these savings are now being passed on to developers and API users. Completing this course should normally fall under the free tier, or in any case, you shouldn't pay more than a few bucks depending on how you'll use the service. I just want you to be aware of the fact that the OpenAI service is not completely free, and at some point you may have to add a credit card. The pricing model is simple, flexible, and open. You pay only for what you use, and anytime you want, you can check your usage at this address. You can also manage your spendings by configuring usage limits. For example, you can set up a $10 monthly limit once you are under the paid plan. Just go to usage limits under the billing section of the main menu. Let's go ahead and see what the price structure is. For language models, the prices are set for 1000 tokens. For example, for ChatGPT, which uses a model called GPT 3.5 Turbo, you'll pay 0.2 cents for 1000 tokens. The DaVinci model, which is also extremely powerful, costs 2 cents for each 1000 tokens. And the 4o, which is the fastest, you'll pay 0.05 cents per 1000 tokens. We'll discuss tokens and other specific terms in depth in another lecture, but for the moment, think of a token as a chunk of characters. The AI models will process the text by breaking it down into tokens. According to the OpenAI documentation, a token is approximately 4 characters in English, or simply put, 100 tokens equals 75 words. Both the input, what you ask, and the output, what you get back, count as tokens. For DALL-E, which is an image generation model, you'll pay for each generated image depending on its resolution. For the highest resolution, you'll pay 2 cents, and for the lowest resolution, you'll pay 1.6 cents. Be aware that the prices could change at any moment, so it's possible that when you watch this video, another prices will be available. You should check them on the pricing page prior to using the AI models so that they won't come as a surprise to you. Hi guys, up until now, you've already heard me saying the word token many times. Tokens are of special interest to us because we pay per token and the entire interaction with a specific model is limited to a maximum number of tokens. The maximum token limit for GPT 3.5 Turbo is 4096. So what are tokens? Tokens can be thought of as pieces of words. Before the API processes the prompt, the input is broken down into tokens. Tokens can be words or just chunks of characters. As a rough rule of thumb, one token is approximately 4 characters or 0.75 words for English text. To see how many tokens are in a text string, you can use the OpenAI Python library called TickToken, or use the interactive tokenizer tool. It allows you to calculate the number of tokens and see how the text is broken into tokens. For example, hello, OpenAI. This text consists of 4 tokens. Here, you can also see how the text was broken down into tokens. But ChatGPT is powered by GPT 3.5 Turbo. This string consists of 16 tokens. Note that when you make an API call, both input and output tokens count toward these quantities. For example, if your API call used 20 tokens in the message input and you received 30 tokens in the message output, you have actually used 50 tokens and will be billed for this amount. This is somewhat general because you can't simply add the number of tokens in the input to the number of tokens in the output and get the total number of tokens in an API call. There's also some overhead. In addition to the content, so the prompt passed to the API, there are other fields that consume tokens, such as role, other fields, and a few extra for behind-the-scenes formatting. If you want to see the exact number of tokens consumed by an API call, check the usage field in the API response. Let me show you how to do that. I'm asking ChatGPT what is the name of the longest river in the world. I'm running the notebook. Okay, this is a good answer. Now, take a look at the usage field. Here, you'll see the completion, the prompt, and the total tokens. For example, this API call consumed 24 tokens. Okay, in this video, we've learned about tokens. We are taking a short break, and in the next lecture, we'll go over OpenAI models completion parameters. I'll see you soon. In this video, we'll go over model text completion parameters. When you make an API call, besides the prompt, you can send many other options so that you can influence the output of the model. You can test these parameters in the playground, or you can make API requests and see the output. If you test them in the playground, you should adjust these parameters: temperature, maximum length, stop sequence, top P, and so on. You are now learning how to use the OpenAI API with Python, so let's see some code. We are starting from this basic example. This is the question I am asking. And the first parameter is temperature. The temperature is a parameter that controls how much randomness is in the output. OpenAI models are non-deterministic, meaning that identical inputs can produce different outputs. The higher the temperature, the more random the answer will be. The temperature can be between 0 and 2, and the default value is 1. If you set it to 0, the model outputs will be mostly deterministic, and if you increase it, the output will be more diverse, but with a high probability of being prone to errors. The rule of thumb is that you'll use a lower temperature when there are just a few answers, or even a single one, and a higher temperature when you want to generate ideas or a complete story. Think of it as a creative setting of the model. Let's set the temperature very low to 0.2. Now it will give me the most probable answer, and if I run it many times, I'll always get the same answer. I'm running all the cells in this notebook. Okay, I've got this answer. Note that even if you use a temperature of 0, there's still some randomness in the answer. I've got a good answer, but it's like a standard one. Things that we've probably already known, and there's nothing creative in it. If I set the temperature to a higher value, let's say 1, or even higher, it will be more creative. The answer will vary with each call, but the model can also hallucinate. Okay, I'm setting the temperature to 1.8 and running the code again. You can see that this is not a standard answer anymore. It's more creative, but it can also contain nonsenses. And there's a lot of gibberish here. Another option is top_p, aka nucleus sampling, which is an alternative to temperature. Its default is 1, and if you set it to another value, let's say 0.2, it means that only the tokens comprising the top 20 probability mass are taken into consideration. So 1 means use all tokens in the vocabulary, while 0.2 means use only the 20% most common tokens. It's generally recommended to alter either top P or temperature, but not both. Let's change the prompt and set top P to 0.1. The prompt will be write one sentence review of 1984 by George Orwell. I'm running it. Another useful parameter is max tokens. This is in fact the completion tokens from the response object, or the maximum number of tokens allowed for the generated answer. For the GPT 3.5 Turbo model, the default value is 4096 minus the number of tokens in the prompt. You can set it to an arbitrary number to limit the response to a certain length. Note that this may cause issues if you set the max tokens value too low, because the output will be cut off and the result will not make sense to the users. I'm setting max tokens to 10. And I'm making the request again. And we see how the answer was cut off. N is another parameter and indicates how many chat completion choices to be generated for each input prompt. By default, it is set to 1, which means it will give only one answer. This is essentially the same thing as running the same prompt multiple times. I'm changing the prompt to give me a motto for an ice cream shop. The temperature will be 1.5 because I want it to be very creative. Top P will be 1, the default. And N will be 2. I want 2 completions or 2 answers. And I'm printing the second answer. This is in fact the second element of the list. You can print the entire response object to see how it is structured. I'm running it. Let's go ahead and talk about the stop sequence. This is another parameter used to make the model stop at a desired point, such as the end of a sentence or a list. For example, if you want single-line completions, you'll use the return key as the stop sequence. Let's see an example. I'll instruct the model to generate an SQL select query for me, and I'll use the semicolon for the stop option. This means that the response will end after the query because each SQL query ends with a semicolon. Write an example of a select SQL query. First, I'm making the call without the stop option. Okay, I'm setting end to 1 and I'm removing the second answer. It generated a random query and it also gave some information about it. Now I'm adding stop equals semicolon and I'm running the code again. And we notice how it stopped at the end of the query just after the semicolon, which is the stop sequence. You can use up to 4 stop sequences, and in that case, you'll have a list. Like this. Let's go over the last 2 parameters, frequency and presence penalties. The frequency penalty is by default 0 and can be set between -2 and +2. Positive values penalize new tokens if they already exist in the text generated so far. The higher the value, the lower the probability of the model repeating the same phrases or words. I want ChatGPT to write an article about coffee because everybody loves coffee. I'm changing the prompt to write a short article about coffee. I'm setting the temperature to its default value and I'm commenting the stop sequence. And I'll use here a larger value. Let's say 1000. I'm running it. This is an article generated with a frequency penalty of 0, the default. If I increase the value, I'll suppress repetition or the model's likelihood to repeat itself. However, this can degrade the quality of the samples. I'm setting it to 1. Now, the probability to repeat words is much lower. But if I set it to a negative value, it's more probable to start repeating itself. I'm setting it to minus 0.2. If you set it too low, it can even give gibberish by repeating the words. Let's try minus 1. Okay, there's a lot of gibberish. The last parameter, presence penalty, is similar to frequency penalty. As frequency penalty, it is by default 0 and can be set between -2 and +2. According to official API documentation, the presence penalty is a one-off additive contribution that applies to all tokens that have been sampled at least once, and the frequency penalty is a contribution that is proportional to how often a particular token has already been sampled. Okay, I think that's enough. And what you should do now is play around with all these parameters and experience how the model reacts to changes. Hi guys! In this video, we'll go over ChatGPT system role. We are starting with this example. As you can see, there's no system message. However, a good practice is to use a system message to instruct the assistant to respond in a specific way or to have a specific personality or behavior. I'm adding the system role. So, system role content equals you explain concepts in depth using simple terms and you give examples. I'm typing a backslash and I continue the string on the next line to help people learn. At the end of each explanation, you ask a question to check for understanding. Now I'm adding the system role to the messages. So, role, colon, system, and the content, colon, and the variable. I'm also increasing the max tokens. This was the previous answer, and I'm running the code again. Okay, I forgot the comma. And you notice how it answered in great detail and also ended the completion with a question to check for understanding. Let's change the system role message to this one. System role content equals you are a concise assistant. You reply briefly with no elaboration. I'm running it. And you notice how differently it has answered. You can even prime the assistant with another personality or behavior. I want it to play the role of Master Yoda. So you reply in the style of Yoda character from Star Wars. I'm running it. Cool, isn't it? Okay, we'll take a break, and up next, we'll dive deeper into prompt engineering. In this lecture, we'll go over prompt engineering. Today, this is considered to be one of the hottest jobs with some of the highest salaries in the IT industry. Let's talk about the best practices for prompt engineering with OpenAI API. For the OpenAI family of models, there are specific prompt formats that work particularly well and align better with the tasks at hand. I'll provide you with a number of prompt formats that I personally find to work reliably well. However, you can also explore different formats which may fit your own tasks better. Note that I'll refer to the API and not to the web interface of ChatGPT. However, in general, the same rules are applicable and you can always try a Google search for ChatGPT prompt engineering. You'll find plenty of videos, articles, blog posts, or even cheat sheets. Okay, let's get started. The first recommendation is to use the latest model. For the best results, I recommend you use the latest and most capable models. Take a look at available models on the OpenAI website. Put the instructions at the beginning of the prompt on their own line and separate the instructions from the context. Let's see an example. This is a good prompt. So, translate the text below from English to German. And this will be a multi-line string. So, I'm using triple quotes. A new line and the text to be translated. By the way, a text between curly braces is a placeholder for the actual text or context. I'm running it. And I've got the translation from English to German. Another good idea is to be specific and descriptive. Be specific, descriptive, and as detailed as possible about the desired context, outcome, length, format, style, and so on. Let's see a good prompt. So, user prompt equals configure BGP on 2 routers. By the way, BGP is a routing protocol. This prompt is good, but it's not the best. I'm running it. And I've got the configuration. Let's see a better prompt. A better prompt would be something like this. Configure BGP on 2 routers and then explain in detail each command. And I'll also give it some instructions. Okay, this will be a multi-line string too. So, the routers run in the same AS. AS means autonomous system. The AS number is and the random one. And the configure authentication using MD5 and password and a random password. Okay, I'm running the code. Good, I've got the desired response. The configuration for the routers is as I requested. Let's see another one. Start with zero shot. If the results are not optimal, fine-tune by providing a couple of examples. Let's see a good prompt. Extract keywords from the below text. And the text, colon, and the text in curly braces. Let's try something about Python. I'm copy-pasting this text. And I arrange it a little bit. I want to see the entire text on the screen. And the keywords, colon. I hope it will complete with the keywords. I'm running it. Good. Let's try a better one. I'll give an example. So, text 1, colon, and I'm pasting a text and the keywords. Sorry, it's text 2 here. Text 1 and text 2. And the same for keywords. This is a better prompt. I'm running it. Okay, let's see another example. Reduce fluffy and imprecise descriptions. This prompt is not so good. The description for the product below should be fairly short, a few sentences only, and not too much more. And the product will be Rubik's Cube. I'm running it. I'll get the product description. However, we can use a better prompt. For example, write a description of 3 to 5 sentences for the product below. And the same product. This is better. Let's see another one. Don't say what not to do, say what to do instead. Let's see an example. The following is a conversation between an agent and a customer. Do not ask for username or password. Do not repeat. Customer, colon, I can't log into my account. And now the agent. I'm running it. Okay. Let's try a better prompt. The agent will attempt to diagnose the problem and suggest a solution without asking any questions related to the username and password. Instead of asking for credentials, refer the user to the help article and a web address. This is a better prompt. Let's see the last recommendation. If you want to instruct the model to generate some code, give hints to push it to a particular pattern. So give hints. This is not so good. Write a simple function that asks the user for the temperature in Fahrenheit and converts the temperature to Celsius. It doesn't know what language to use. I'm running it. Okay, it gave me a Python function. But what if I want the function in JavaScript? I can give it a hint. For example, function and the curly braces. This is a hint. Here adding function curly braces hints to the model that it should start writing in JavaScript. I'm running it. Now I've got a JavaScript function. Similarly, import or select are good hints for Python or SQL. Now I'll get a Python function. Okay, that's it. Happy prompting. In this video, I'll show you how to generate images from a textual description using the DALL-E model and the OpenAI API. But first, let's see what DALL-E is. I'll ask ChatGPT. What is DALL-E? And I'm getting a pretty good answer. What I want you to notice is that the name DALL-E is a combination of the artist Salvador Dali and the character Eve from the movie WALL-E. So in a nutshell, the DALL-E API provides you with ways to create original images from scratch based on a text prompt, to create edits of an existing image based on a new text prompt, and also to create variations of an existing image. DALL-E is just a neural network that was trained to create images from text descriptions. I also want to point out that when we are talking about DALL-E, we are referring to DALL-E 2, which is the second version of DALL-E. Let's go ahead and see how to create a DALL-E request using the OpenAI and Python. Let's ask ChatGPT as well. And the AI model is answering with the required steps. We can also see a piece of code. That's really cool. Let's move to Jupyter Notebook. I've already imported the OpenAI and OS modules, and I've loaded the API key into an environment variable. To create such an image, we'll need a prompt, which is a text description of the image. So, image prompt equals. Let's try a description. Man on a motorcycle, on a cyberpunk street, high quality photography. The more detailed the description, the more likely you are to get the wanted result. For inspiration, you can find some prompt examples at labs.openai.com. You see the prompt and the image. Now I'm making the request. This is similar to creating a GPT text request, just that it has fewer parameters. So response equals openai.image.create. Prompt equals prompt, and n equals 1. N means the number of images to generate. And also size equals 1024 times 1024. And I'm printing the response. I'm running it. Okay, it's image prompt, not prompt. The name of the variable, of my variable. And I've got something similar to the text ChatGPT response. If you take a closer look at the JSON response, you'll see the image URL. This is the image URL. So image URL equals response of data, the name of the key, of 0, this is a list, the value of the key data is a list, and there's only one element, and URL. I'm printing it. Okay, it looks pretty cool. Let's save the image to a file on disk. We can do that by switching the response format, this one, from a URL to the base64 encoded image data, or we can leave the URL response format and get the image using requests. In this example, I'm using requests because we already have the image URL. Note that requests is not a Python standard library and it should be installed. So pip install -q requests. Okay, I'm importing two libraries, requests and shootil. Shootil is used to copy files. I'm making an HTTP request using the requests library. It's like getting the image using the browser. So resource equals requests dot get of image URL and stream equals true. Stream equals true is necessary to get the raw content of the response. This is an HTTP response object which has a status code. 200 means success, and the codes that start with 4 mean error. I'm sure you are already thinking of the meaning of code 404, page not found, or code 403, which is forbidden. Let's print the status code. So print resource dot status code. And it's 200. If code equals 200, I'll save the image to the disk. So if resource.statuscode equals 200, and here I'll have the code that saves the image to disk. Else, print, and I'm printing a message. Error accessing the image. And the code to save the image. With open the name of the file, let's say dali1.png, WMB. I'm opening the file in write and binary mode. Using util and the copy file object function, I'm copying the raw content of the HTTP response to the file. So util .copy file object of resource .raw and f. And here, of course, I'm opening the file as f. F is the file object. I'm running the code. There's no error. And a new file was created in the current directory. This is the file. It's the image. You can also display the image directly in Jupyter Notebook using the PIL library. I'm importing it from PIL, written in capitals, import image. I'm importing the image class. PIL stands for Python Image Library. And the image.open and the name of the file, dali1.png. And I'm running it. Okay, I've got an error. Of course, the library should be installed as well. It's not a Python standard library. So pip install Pillow. Pillow is the name of the library. Okay, it's installing it. It was successfully installed, and I'm running this code cell again. And the image was displayed in Jupyter Notebook. In this video, you've learned how to generate original images using DALL-E and how to save them on disk. As a summary, after authenticating to OpenAI, you call image.create with a very descriptive prompt. Now we'll move on. In the next video, we'll discuss creating and editing images using DALL-E. In the last video, we went over creating original images with DALL-E. Let's go ahead and see how to create variations and edit images using DALL-E. In addition to creating new original images, DALL-E can even modify existing ones, create variations of the image that maintain their features, and interpolate between two input images. Let's see how to create variations of an image with the OpenAI API and Python. Having an image that was generated by DALL-E or not, you can create variations of it using OpenAI's DALL-E Latent Diffusion Model. This is the image I have, and I want one or more variations of it. The image should be in PNG format. The first step is to open the existing image, as usual, by calling the open function. So image equals open, the name of the image, original.png, and RB. Note that the file is a binary one, so I have to read it in binary mode. Next, I'll call the createVariation method of the image class. So response, this will be the response, OpenAI dot image dot create variation. And image equals image, n equals 1. This is the number of variations, and because I pay for each image, I only want one. And the size equals 1024 times 1024. Let's take the image URL in a variable and print it. So image URL equals response of data of 0 and the URL. Remember how we did in the previous video when we generated an original image. And I'm printing the image URL. This is the variation. This is the variation, and this is the original. Let's go ahead and see how to edit an existing image. I'll generate a new image using the DALL-E editor interface, which can be accessed at this address, labs.openai.com/editor. If you want, you can generate the image from Python using the OpenAI API, or you can take any other existing image. Here in DALL-E editor, I'll use the following prompt. John Wick riding a motorcycle on an apocalyptic field in a cyberpunk look, high quality photography. I'm generating it. Note that DALL-E works better with longer and more detailed input descriptions. Simpler sentences are not good enough because they are way too general. Remember, DALL-E 2 is really good at handling complexity. And I see here some images. Okay, let's take this one. I'm saving the image. I'm also moving the image in Jupyter Notebooks root here. Probably it's in the download folder. Okay, I have moved the image, but I also want to rename it. It has a name way too long. Let's say motorcycle original. The image was generated, and though it is good, it is not the best. I want more control over my creative work. For example, I want the image to contain a red moon in an exact part of it. So I want to create a variation of it. To create a variation, I'll need the original image and a mask. The mask is in fact the same image with a transparent area that indicates where the image should be edited. So here in the editor, using the eraser tool, I'll create a transparent area. Note that you can use any image, not only images generated by DALL-E, and you can also create the mask in any other photo editor. I'm saving the mask and I'm moving it to the notebook directory. Okay, I've done it. The image is in the notebook directory and I'm renaming it to mask. Mask.png. Okay, this is the mask. In the notebooks directory, I have both the original image and the mask. I'm creating a file object by opening the original image as usual. So image equals open, the name of the image, motorcycle original, and RB. And RB the mode. The image used as the basis for the variation must be a valid PNG file less than 4 megabytes and square. I'm also opening the mask. Now, I'm creating the response object by calling OpenAI.image.createEdit. So, response equals OpenAI.image.createEdit. Image equals image, mask equals mask. This is the method's argument, and this is my variable. And the prompt. The prompt should describe the full new image, not just the erased area. So I'm copy pasting the prompt into Jupyter Notebook. And I'm adding containing a big red moon. So John Wick riding a motorcycle on an apocalyptic field containing a big red moon in a cyberpunk look. High quality photography. N equals 1, the number of images to generate, and must be between 1 and 10, and the size. And the image URL. Image URL equals response of data of 0 and of URL. And I'm printing it. I'm running it. Okay, there's an error. I forgot the comma after the prompt. And I noticed another error, sorry. Here is response. I'm running it again. Okay, this is the new image URL and I'm clicking it. We see that the new image contains a big red moon exactly in the transparent area of the mask. That's it. Up next, we'll dive deeper into DALL-E and see how it works behind the scenes. Welcome back. In the last videos, we saw how to create new original and realistic images from text descriptions, how to create variations, and how to edit images using the OpenAI API, DALL-E, and Python. Let's go deeper into it and see how it works behind the scenes. DALL-E is a trained neural network that, according to the official OpenAI documentation, is a version of GPT-3 that uses a dataset of text images pairs. Like GPT-3, DALL-E is a transformer language model. I won't dive too deep into DALL-E's internals. It is out of the scope of this course, which is intended to be practical as much as possible. However, you should know that these transformers are a new type of neural network that can be scaled up and trained on huge datasets. These transformers are considered revolutionary in natural language processing and are used by many AI models such as BERT. This one, for example, is currently being used by Google to optimize the interpretation of user search queries. Other models that use transformers are GPT-3 and the GPT-3.5 of OpenAI, and even AlphaFold of DeepMind that can predict the 3D structure of proteins. If you want to dive really deep into it, you'll have the Transformers paper attached to this video. Let's take a look at a high-level overview of the DALL-E text-to-image generation process. This is from the paper where DALL-E was described. Look at this image. This is a multi-step process. A text encoder takes the text prompt and generates the text embeddings. These text embeddings are a numeric representation of the input and serve as the input for a model called the prior. It generates the corresponding image embeddings. Finally, an image decoder model generates an actual image from the embeddings. It sounds straightforward, but lots of things happen under the hood. From a text description, DALL-E will generate a large set of images, and the images will be then ranked by a second OpenAI neural network called CLIP that tries to determine which of the images match best. CLIP has two components, a text encoder and an image encoder, and was trained on 400 million pairs of images with text captions scraped from the internet. If you want to dive deeper into CLIP internals, you can do it by reading the resources that are attached to this video. At the end of this video, I'd like to talk about DALL-E risks and limitations. Without sufficient guardrails, models like DALL-E could be used to generate a wide range of deceptive and otherwise harmful content, and this could affect how people perceive the authenticity of content more generally. AI models like DALL-E traditionally inherit various biases from their training data, and its outputs could reinforce social stereotypes. Welcome back. In this video, we'll cover the Whisper model, which is a speech recognition one. By the end of this video, you'll be able to transcribe audio into whatever language it is and translate the transcription into English. This is really cool, so stay with me. Whisper is a trained open source neural network that approaches human-like robustness and accuracy on English speech recognition. The model supports tens of languages and was trained on hundreds of thousands of multilingual and multitask supervised data collected from the internet. The OpenAI API provides two endpoints, transcriptions and translations, based on the state-of-art open source Whisper model. Practically, you can use this model to transcribe audio into whatever language the audio is in, or to translate and transcribe the audio into English. Let's import the required libraries and set the API key as an environment variable. In the first example, I'll use Whisper to create the transcript of an audio file. I'll use a small part of President Ronald Reagan's speech to the people of West Berlin from July 12, 1987. It's the famous "Tear Down This Wall" speech. This is the audio file, and this is the official transcript. I'm playing the file. There are just a few phrases, so let's listen to the audio so that we can compare to what Whisper will do. This part is 1 minute and 30 seconds long, and you can fast forward if you don't want to listen to it entirely.
We welcome change and openness. for we believe that freedom and security go together, that the advance of human liberty can only strengthen the cause of world peace. There is one sign the Soviets can make that would be unmistakable, that would advance dramatically the cause of freedom and peace. General Secretary Gorbachev, if you seek peace, if you seek prosperity for the Soviet Union and Eastern Europe, if you seek liberalization, come here to this gate. Mr. Gorbachev, open this gate. Mr. Gorbachev, tear down this wall.
Okay, that was the audio, so let's put Whisper to work. We open the file in binary mode as usual. So with open the name of the file, rr.mp3, the file is in the same directory here, and it will be opened read-only and in binary mode as audio file. Now I'll call OpenAI.audio.transcribe. So OpenAI.audio with capital A dot transcribe. This method will return a transcript object. So let's say transcript equals. The method will take two arguments. The name of the model is Whisper1 and the file object, audio file. By default, the response type will be JSON with the raw text included. I'm printing the transcript. Okay, I'm running it. Very well. We notice that the transcript is quite good. Note that the audio files are currently limited to 25 megabytes and the input files that are supported are MP3, MP4, MPEG, M4A, and WAV. Besides transcription, Whisper is also capable of translating into English. Let's go ahead and do an automatic translation. I have this sample audio in German that is a story for children. Let's listen for a few seconds.
Oh yeah.
Toll, Papa. Echt toll hier bei den Löwen. Nur dieser Löwe hier, deiner Beku, ist nicht da. Schläft wahrscheinlich in, oder?
If you listen to the file, you'll hear some background noise and other sounds. You might think that could create problems, but it's not the case. Whisper has improved robustness to accents, background noise, and the technical language. The Translations API takes as input the audio file in any of the supported languages and transcribes it into English. So, audio file equals, and I'm opening it as usual. So, German.mp3 and RB. And the transcript equals OpenAI.audio.translate. The first argument is the name of the model, Whisper1, and the second argument, the file that will be translated. So audio file. And I'm printing the transcript. The raw text is the value of the key named text. So transcript of text. I'm running it. And it looks pretty good, isn't it? And don't forget to close the file. So audio file dot close. Okay, we are done. You now have a good understanding of how to use Whisper to transcribe audio into whatever language the audio is in, or to translate the audio into English. In this project, we'll build a ChatGPT clone from scratch. This can be integrated into any application that requires building dialogues, like for example a customer support application. We'll use the model GPT 3.5 Turbo from OpenAI. It's the same model used by ChatGPT. This model interacts in a conversational way, and the dialogue format makes it possible to answer follow-up questions, challenge incorrect premises, or reject inappropriate requests. Let me show you the functionalities of the final version of the script. I'm running it and starting to ask questions that are related. I want to make a dialogue. I'm setting the system prompt. If I leave it empty, it will use a default system prompt. Let's say you are a concisely assistant. And the first question: what is the age of Mars? And I'm waiting for the answer. Note that I've misspelled the word of, but it will understand the context. It's really smart. Great. It answered correctly. The second question: what is its diameter? This question is related to the first one. I'm not saying what I am talking about. It has to deduce that we are talking about Mars. Perfect. And what is its mass? And the next one, what are we talking about? It answered correctly. And finally, are we talking about Jupiter? Planet Jupiter. That's really smart. We notice how the chatbot answered. It gave us correct answers, and that's really cool. We have a custom and configurable ChatGPT in our application. Now you can add AI to your software products. These are the requirements. We are taking a short break, and in the next videos, we'll go over this project step by step. Welcome back. Let's start building the project. In this lecture, we'll start making a dialogue in the ChatGPT style. At the beginning, the dialogue will consist of only 3 questions, and then we'll generalize it for any number of questions. We are starting from scratch. We are importing the required modules: OpenAI and OS. Now I'm setting the API key. The API key is saved in a file in the current directory. So OpenAI.API key equals open the name of the file key.txt .read .strip of \n. This is optional. Next, I'll define the questions which should be related because I want to have a dialogue with the GPT model. The questions will be hard-coded, but you can easily prompt the user using the input function or read them from a file. Let's ask something useful. What are the healthiest foods to eat every day? And the second question, make a recipe with those foods. And the last question, what is the amount of calories? Now I'm creating the messages structure for the first API request. I have 3 questions to ask, so I'm gonna make 3 API calls, 1 call for each question. So messages equals, and it's a list of dictionaries. The system message helps set the behavior of the assistant. So role system and the content, answer as concisely as possible. Now the user message. This contains what I'll ask the assistant. Role user and the content colon Q1, the first question. I'm creating the chat completion object which contains the response. So response equals OpenAI dot chat completion dot create. Model equals and the name of the model GPT 3.5 Turbo. Messages equals messages. I'm also setting the temperature. Temperature equals 0.7. And I'm leaving the other parameters to their default values. And the first response. Let's say bot response 1 equals response dot choices of 0 of message and of content. And I'm printing it, the response. Okay, there's a small error. Here it's OpenAI. I'm running the script. And another one, here it's Q2, the second question, it's Q2. I'm running the script. And we notice how concisely it has answered. I'll submit 3 questions and I'll get 3 answers. For readability, I'm adding a new line and some dashes in between the questions and answers. So print, this is an empty line, print dash times 50, I'm printing 50 dashes and another new line. Let's define the messages structure for the second question. This becomes interesting and is the key to building a dialogue which is a multi-turn conversation. The first messages structure had only two roles: system and user. Now, to answer the second question, which could be related to the first one, ChatGPT needs the entire context. This means that this time messages will contain the current question, the second one, but also the first question and its answer. Because the model has no memory of past requests, all relevant information must be supplied. I'm copying the first message and I'm adding two new objects: an assistant role that has as content the first response and a new user role for the second question, the current one. This is the second question. So, comma, and the assistant role. And the content will be the first answer. So content, colon, bot response 1. And the second question, the current one. So, role user and the content Q2. And I'm making the API call for the second question. And I'm saving the answer into another variable. It will be bot response to, and I'm printing it. I'm running the script. This is the answer to the first question, and I'm still waiting for the second answer. Oh, this seems delicious. Let's do the same for the third question. I'm creating a new messages structure. This time, I'll add for the dialogue context the first questions with their answers and the third one. And finally, I'm creating the chat completion object. And I'm printing the third answer. I'm copy pasting the code. This is bot response 3 and here 3 as well. I'm also adding the blank lines and the dashes between responses. I'm running it. This is the first answer, and I'm waiting for the second one. The second answer was displayed. Notice that its answers are not deterministic. It answered differently. And the final answer, the third one. Great! We managed to build a dialogue or a multi-turn conversation. We are taking a break, and in the next lecture, I'll show you how to generalize the dialogue for any number of questions. I'll see you soon. Let's continue our project. In the last video, we managed to build a dialogue that contains 3 questions with answers. Now, I'll generalize it for any number of questions. I'll save all questions asked by the user in a list. Maybe later I want to save them to a file or to a spreadsheet. So, questions equals empty list. And I'll do the same for the responses I get from the GPT model. So both responses equals list. Let's construct the messages structure. Messages is a list, so I'm starting from an empty one. I'm adding the system role to the messages list. So system prompt equals answer as concisely as possible. You can prompt the user for the system role using the input function, or you can hard code it. We'll do that shortly. And messages append and a dictionary. Messages is a list of dictionaries. So role system and the content colon system prompt, the variable I've just defined. Next, I'll enter a while loop. So while true. While true means that the loop will run indefinitely because I want the dialog to have as many questions as I wish. The loop and the program will end when the user enters exit or quit. In that case, I'll execute a break statement. I'm prompting the user for the current question. So current question equals input and the text will be me. This is like a prompt. I'm testing if the user entered exit or quit. If yes, I'm breaking out of the while loop. So if current question dot lower in and a list of strings exit and quit colon and the if block code. I'm testing the lowercase version of the current question so that the user can enter exit or quit in upper, lower, or mixed case letters. I'm printing a message and then quitting. So print, let's say chatbot, colon, I was happy to assist you, bye bye. I can wait for 2 seconds before exiting. I think it looks better. So time.sleep of 2. And break. And of course, I'm importing the time module. If the user is just pressing enter, so there's no question, I'll continue with the next iteration. So if current question equals empty string, colon, continue. By the way, if you don't master these Python key concepts like break and continue, you can take a look at my complete Python bootcamp because I've dived really deep into them. I have the current question and I'm adding the user role to the messages. So messages dot append and a dictionary role colon user content colon current question. I'm creating the chat completion request. Response equals OpenAI dot chat completion dot create. Model equals GPT 3.5 turbo. 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 3.5 messages equals messages, and the temperature equals 0.7. Next, I'll set the max tokens parameter to a high enough value so that it can hold a dialog. Let's say max tokens equals 3000. Or I can leave it to its default. I remind you that max tokens is the maximum number of tokens allowed for the generated answer. I think I'm gonna leave it to its default value. I'm saving the current response in a variable, printing it to the terminal and appending it to the bot responses list. So current response equals response.choices of 0 of message of content. And I'm printing it. By the way, I'm adding a \n at the beginning. Chatbot colon, and this will be an F string. Current response. And I'm appending it to the bot responses list. And finally, before finishing the current iteration of the while loop, I'll add the ChatGPT answer to the messages list as the content of the assistant role. This is necessary to save the context that is required for the next question. So messages.append and a dictionary. Role colon assistant and the content colon current response. The last statement of the while loop will be printing 50 dashes for a better readability. So print \n plus dash times 50. And another \n. This will be added after each answer and before the next question. Okay, there's a small issue on this line. So the closing single quote should be at the end of the string. Here. Okay, let's take a quick look at the entire script. I want to make sure that I didn't miss anything. Okay, here for example, I forgot to add the current question to the questions list. After adding the current question to the messages, I'm adding it to the questions list as well. So questions.append of current question. We are done. This is my solution to the project. Of course, you can improve it here and there, add a fancy web or desktop interface, add different features, and so on. But the logic and the main idea will remain the same. We'll take a break, and in the next video, we'll test the program. Welcome back. In the last video, we developed this script that creates a ChatGPT clone using the OpenAI API and Python. Let's test it. I'm running the cell. I'm asking a few questions. The first one will be, write a summary of the book 1984. By the way, this is one of my favorite books. Okay, I've got a good answer. And the next question, who wrote it? And of course, it was written by George Orwell. When was the book first published? And I've got the answer. Now I want to check that it knows the context. What are we talking about? And it knows the context. Now, write a poem about the sun. Let's see how creative it is. I'm changing the context. And I've got a poem about the sun. Translated to Spanish. Great! Our chatbot is working very well. I'm exiting. Let's play with it. I'm changing the system's role of the messages so that its content is entered by the user. Now it's hard-coded. System prompt equals input and the system prompt. This is the string that will be displayed. And if a system prompt is empty, this means that the user hit enter. I'll use this default value. So if system prompt equals empty string, colon, and I am indenting this line. I'm running it again. It's prompting for the system role, and I'm writing, you will answer in German, no matter what language I will ask you. Okay, write a summary about quantum mechanics. Let's see if I get the answer in German. And of course, I got a summary about quantum mechanics in German. That's really cool. Let's try another system role. You will answer in the style of the Blackbird pirate. Who are you? This is the first question. Okay, of course, you are the Blackbird pirate. How old are you? Okay, you are very old. And where do you live? I really like this answer. I'm quitting. Let's see the last example. Act as an experienced programmer. I will give you a request, and your only output will be the code. Let's try something simple. Fibonacci sequence in Java. I want the code that generates the Fibonacci sequence. And I've got the Java code for the Fibonacci sequence. Now, let's see the Python version. Okay, I've misspelled the word Python. I didn't make it on purpose, but I want to see if it understands that I want the code in Python. Let's see how smart it is. And as you can see, it understood very well. Now I want ChatGPT to write an Ethereum smart contract. So Ethereum ERC20 token called Cryptos. And I've got the smart contract. Now I can deploy it on the Ethereum blockchain and I have my own token. And the last example, linear regression in Python. And I've got a sample code for linear regression in Python. If you have any issues, you can print the messages, the questions, and the responses for debugging purposes. For example, here at the end, I'm printing an empty line, and I'm creating a dictionary using the zip function. The questions will be the keys and the bot responses the answers. So dict zip questions, comma, bot responses. Another empty line, and I'm printing the messages. This is for debugging purposes, and I'm running it again. What is the largest city in the world? Okay, it's Tokyo. What is its population? And I've got the population of Tokyo and what is its area. And I'll get its area. Now I'm quitting. And I see the questions and the answers as a dictionary, a Python dictionary, and I also see the messages. That's it. In this section, we made a lot of progress. All this knowledge you've acquired will help you become proficient in building the next generation of intelligent applications. But remember, the only way to learn is to really write code by yourself.